Greetings to all the viewers. The session is going to cover with the intermediate chemistry. We'll be fetching for your international entrance and competitive exams. India is conducting JEE Advanced and JEE means examination to get the admission into IIT and NIT stream. NEET exam will be conducted all across India for the admission into this technical stream. Medical entrance examination it will be, right? So MCET exam will be conducted to get the admission into the BTech stream. Government organizations are conducting competitive exams where you can get the entrance into various job opportunities. Their general studies common question paper is available. General science content will be there. Let's go with the question number 1. Here is the scientist who contributed for the 1990 Nobel Prize in the field of chemistry, Elias James Corey. So he contributed alone for this year's Nobel Prize. The Nobel Prize in the chemistry for the year 1990 was awarded to Elias James Corey for his development theory and methodology of organic synthesis. He made his contributions for the theoretical assumptions and pathways in order to synthesize the organic compounds. Hence, he was accorded with the prestigious world recognition called Nobel Prize in the year 1990 in the field of chemistry. Let's go with the brief info regarding the scientist. The Royal Swedish Academy of the Sciences has decided to award 1990 Nobel Prize in the field of chemistry to Professor Elias James Corey, Harvard University, Cambridge, Massachusetts, United States of America, for his development of theory and methodology of the organic synthesis. He made his contributions in the field of synthetic organic chemistry, and new methodologies and theoretical assumptions were made so that it was accorded with the Nobel Prize. Let's see what research contributions he made. The development of the art of organic synthesis during the little over the 100 years that afforded efficient methods of manufacturing products such as plastics and other artificial fibers, paints and dyes, biocides and pharmaceutical products, all of which have contributed to the high standards of living, health, longevity enjoyed the least in the Western world. This is the way the year 1990 Nobel Prize is accorded to the synthetic organic chemistry, where it flourished with the way, fibers, paints, dyes, biocides, pharmaceutical products, etc. These many kind of various kind of applications we can find for the synthetic protocols, whatever developed. This year's Nobel Prize in the chemistry has awarded to the Professor Elias J. Corey, United States of America, for his important contributions to synthetic organic chemistry. He has developed theories and methods that have made it possible to produce large variety of biologically high active, complicated natural products, thereby making among their things certain pharmaceuticals commercially available, right? So whatever methodology he assumed as well as implemented, established, that was explorated into various domains so that natural product synthesis was carried and making among other compounds, pharmaceutical, organic pharmaceutical medicines also introduced by the same methodology. Corey's work has also laid a new general methods of producing, synthesizing compound in a simpler ways. Simple method, but high extent of product yield. That is the main motto regarding this formation of the new product. So simple pathways are adopted, and thereby they are going to synthesize the new auxiliary of the compounds. This is the way he contributed alone for the year 1990 Nobel Prize in the field of chemistry. The background of Elias J. Corey's success lays in the fact that the study logical way developed the principles of what is termed as retrosynthetic analysis. He proceeded with the retrosynthesis. Retrosynthesis stands for whatever complicated product moiety is there that will be strategized in order to make a simpler molecules backward direction. This involves the starting from the planned structure of the molecule, which one wish to produce target molecule. Analyzing the bonds must be broken and simplifying the structure by step. Whatever complicated structures are back drawn into the simplified one by step approach. One then finds a certain fragments already known, their structure and synthesis already described. After working backward, the way from which complex are already known to you, so that possible synthesizing a simpler moieties we can go with. This is the backward move. Always the things are going towards the forward direction, but in contrary, this is the kind of backward move. Complicated things are made into a simpler one. It is the new perception. That's the reason why it got laureated with the eminent Nobel Prize. This method has proved by amenable to data processing, which has entailed rapid developments in the synthesis planning, combining the synthetic planning with the singular creativity. Corey has developed new methods of synthesis. He has produced 100 important natural products. For example, active substance in an extract from the ginkgo tree used in the folk medicine in China. This is the way. So whatever things which already existing, those are complicated things are fragmented in such a manner so that new pathways for the synthesis of new unique type of materials with a high pharmacopoeia, high pharmacopotency, and even that is the kind of research objective to go with the new pathways as well. This is the way retrosynthetic analysis got carried by this Elias J. Corey. Hence, it was accorded with the prestigious Nobel Prize. This is the way we can go with the Nobel Prize for Elias James Corey for the year 1990. By this, we conclude question number 1. Let's go with question number 2, collected from Cambridge International Assessment. This question is about zinc and compounds as zinc. Zinc is a metallic compound. Here, can you mention 3 physical properties of any metal which commonly occurred for, right? So zinc react with phosphorus and generate zinc phosphide. Zinc phosphide is a radicalizing agent, no? So that is a kind of material which we can use as a pesticide. Complete the equation for this reaction, zinc plus phosphorus giving rise to zinc phosphide. So here these questions to be answered in a step-by-step manner. First of all, let me introduce zinc over here. Brief information regarding the zinc is provided element of the atomic number 30, and the name is pronounced as zinc and symbolized as Zn. Discovery by Rasaratna Samukha in the year 800. Appearance as a solid one, being it is a metal solid, it will be electronic configuration with the argon noble gas configuration and proceeded with 3d10 4s2. It is not considered as a transition metal, rather it is a d block element of 3d series. Standard atomic weight is provided with 65.38. Covalent radius will be 122.4 picometers. Van der Waals radius is 139 picometers. So this is the way. It is a kind of general physical data regarding this zinc. And isotopes are also available for this one with the abundancy of zinc 64 with 49% composition contribution, zinc 66 with 27 contribution, zinc 68 with 18 contribution, zinc 70 with this minute traces contribution. Their percentage contribution we can note is melting point is denoted with 692 Kelvin. Boiling point is 1180 Kelvin. It will be in order to boil the zinc, extremely larger temperature is required because always metals are accompanied by the highest melting and boiling point values. And the zinc is of completely filled electronic configuration. You can clearly observe. This is brief information regarding zinc metal. And the general properties of metals are indicated. Melting point of all the metals are represented with the in order to melt them, always they are solid in nature and solid in nature and melts at extremely higher temperature, except mercury. Mercury is the liquid metal, hence it is used in the thermometer for measuring temperature. So being it is having that clear meniscus. The properties to choose mercury as the thermometer liquid, that is because of a few properties. Immediately it used to absorb the heat, and quickly it used to expand whenever heat absorbed, so that quick expansion is possible. That's the reason why temperature, whenever temperature is higher, that liquid mercury also rise up. So that is the way. So quick measure we can observe with the thermometer. If you put the thermometer, what happens? Immediately the liquid portion will rise up. That is because of it's a quick reaction towards the heat. That one thing. And second thing is mercury shows clear meniscus. That means where it is located, that extremely upper surface is said to be a meniscus point, that is clearly visible, easily distinguishable. That is second point to be taken as the mercury in the thermometer. And third is about tailing effect. That means it will not stick on the surface of the glass, rather it is moving up and coming down without any sticking tendency over there. That is the reason why much convenience for this mercury to use as the liquid in the thermometer. And densities, all the metals are occupying the smaller value with the larger mass. Mass by density values are larger, hence the density of most of the metals are large. Right, vary from less than water to very dense of lead. Right, so generally metals are having high density. Aluminium used in the aircraft because of low density. This is said to be water application. So aluminium is the metal, though it is the metal, but the density of this one will be a lower one. That's the reason why it applied in the aircraft manufacturing. Aircraft, being they are flying in the sky, we need to fabricate by means of the less density metals only, so that aluminium is more suitable, being it is a lighter. Then thermal conductivity. All metals are having uniform nature, that we can say conductivity. All the metals are good conductors of heat and what electricity conductivity. Aluminium and stainless steel used in cooking pans. That is because of heat conductivity, right? So heat easily conducted through them, so that aluminum and steel articles are used as the cooking pans. And copper is the most abundantly used electrical conductor. Malleability. Metals can be bent into a different shapes. Whatever fabrication you require, that extent you can fabricate them, so that we can say they are easily malleable. Car body is made of flat steel sheets, right? So we are taking very thin steel sheets because of their malleability of the steel, right? And the strength. Some metals are very strong in nature. Strength of the metals are very strong. Iron. For any kind of heavy constructions or bridges, we can apply iron, and its alloy forms. So that extent of strength they can accompany with electrical conductivity. All good conductors as solids and liquids. Copper and aluminum used to make electrical wires. This is the way general properties of the metals are provided. They asked for any few. Three metallic properties are mentioned, so that we gone through extensive information regarding these physical properties of metals. Let's go with this one. Zinc reacts with phosphorus to form zinc phosphide. Zinc phosphide to be formed. Complete the equation. So in order to complete the equation, this is taken as the a stoichiometric equation. You can put in the comment box. I'm not going to solve this one, so that whatever stoichiometric equation you want to get, so that can be taken as the that can be solved and mentioned in the comment box. Let's go with the question number 3. This is collected from 2014 paper 1 JEE Advanced Question Paper conducted by the National Testing Agency. In the galvanic cell, the salt bridge is the kind of device which is a kind of what transparent glass U tube will be taken. In that we have to fill the agar-agar, and along with that potassium chloride solution. Potassium chloride will be filled inside KCl solution. When filled inside that, having tendency to move in velocity. That's the reason why salt bridge can be used. Salt bridge finds distinctive applications in the galvanic cell. Galvanic cell is the device which used to convert chemical energy into the electrical energy at the expense of redox reaction. Right. So this galvanic cell is accompanied by the salt bridge in order to carry the electrons from one ionic solution to another ionic solution, and in order to separate the two ionic liquids, in order to avoid the junction potential, and mixing of two ionic solutions will be retarded, so that potential over voltage can be minimized, that one, so that multiple applications we can notice for this salt bridge. Stop diffusion of the ions from one electrode to another is the exact answer, being it is the kind of porous bridge used to avoid the movement of ions, rather only electrons will migrate from one electrode to another electrode. Question 3, the correct answer will be option B. For that, we have uh, schematic representation over here. Zinc is taken as an anodic compartment where oxidation process got carried. Copper is made as a cathode where the reduction is the reaction taking place. Zinc is immersed into the zinc sulfate solution. Copper is dipped into copper sulfate solution. These are called electrolytic solutions. And both the compartments are joined together with the U-shaped glass bulb, which are transparent in nature, filled with a KCl solution. Agar-agar filled over, so that agar-agar is the medium where KCl solution is filled up, and their high electron movement is taking place from anodic compartment to cathodic compartment. And here is the voltmeter in order to check the potential difference, whatever originated within the galvanic cell. And this is the cell notation. Zinc is in the contact with the aquated zinc sulfate solution. Metallic copper is in contact with the aqueous copper sulfate solution. Both are joined together with the salt bridge. By this, salt bridge is having multiple application. Among one is diffusion of ions from one electrode to another electrode will be retarded, stopped. So this is the way question 3, option B is the right answer. Let's go with the question number 4 for the reaction. I minus called iodide, ClO3 minus is called chlorate, and in the presence of sulfuric acid, this used to substitute the reaction chloride, and I minus turned into iodine, and H2SO4 converted into HSO4 minus. This is called bisulfate anion. The correct statement in the balanced equation is, so about this, what will be the correct one? Stoichiometric coefficient of sulfate is 6, iodide is oxidized, sulfur is reduced, water is one of the product. So from this, we need to go for the detailed explanation for that one. I minus is called iodide. I minus, negatively charged one turned into a 0. So that I minus is converted into 0, called oxidation process. And wherever ClO3 minus is there, this plus 6 minus 1 plus 5 is there for chlorine, and converted into -1 where reduction taking place. Assigning the oxidation numbers to each and every element, I minus turned into 0, and plus 5 chlorine converted into -1. And here oxygens are accompanied by -2. Here also oxygens always -2 only. Sulfur plus 6 will not be changed. Only the difference you can notice for iodine and chlorine itself, where when we write balanced equation for both the sides, 6I minus can be accompanied with the chlorate ions, and there is a formation of Cl minus, and 3I2 will be generated. So whenever water is added because water to be added for this side in order to balance the oxygen atoms. So here 3 oxygens are there. We need to put 3 moles of water so that oxygens got balanced. Then whenever oxygens balanced, here the question is regarding hydrogens. Hydrogens to be balanced by the addition of H plus. Whenever the sulfuric acid is added for the left hand side, we require to add here 6 H plus are there right hand side, so that 3 moles of H2SO4 when added, 6 H plus again restored. So this is the way hydrogens will be balanced. After balancing the hydrogen, the thing is sulfur and oxygens. That means SO4 got increased for left hand side. So whenever sulfates are increased, we need to balance towards this side by providing bisulfate anions. So that stoichiometry for this will be taken as 3 moles of bisulfates will be generated. Oxidation state of iodine changing from the reactant side we have negative and product side we have 0. So -1 converted into 0, so that 1 electron lost, hence iodide got oxidized. Whereas chlorine +5 to -1, so that 6 electrons undergo oxidation. So this is the way oxidation reduction. So it is the example for the redox reaction. So it will be chlorine got reduced. Sorry, chlorine got +5 converted into -1, so that reduced. Then hydrogen, sulfur, oxygen has same oxidation number. So we are not supposed to change hydrogen, sulfur, and oxygen oxidation numbers. So no reduction in oxidation is possible for these. Water is the one of the reaction product. You can notice water is generated as one of the product. From this data, we have to go for what are the correct answers. Stoichiometric coefficient of HSO4 minus is 6. How many HSO4 minus minus are generated? If you see 3 moles. So stoichiometric coefficient of HS4 minus is 3, but they asked for 6, so that you can strike out. A will not be correct. Iodide is oxidized. Let's see. I minus converted into I naught. That means increase in the oxidation state by releasing electrons, so that we can say it is the oxidation. So you can put the tick mark for option B. Sulfur is reduced. We are not supposed to change hydrogen, sulfur, and oxygen oxidation numbers. So that wherever sulfur mentioned, that you can strike out. Water is one of the product. If you see water is generated as the product, right? So water is one of the product is correct only. Only the thing is stoichiometric coefficient of bisulfate is 3. Iodide is oxidized. Sulfur remains the same. Water is one of the product. So correct answer for question number 4 will be B and D. B, D are the correct answers. Let's go with the question number 5. Question number 5 collected from Telangana EAMCET 2019 question paper. The ratio of the radius of second orbit of lithium +2 to the third orbit of beryllium +3 is. లీథియం +2 యొక్క రెండవ కక్ష, బెరీలియం +3 యొక్క మూడవ కక్ష వ్యాసార్థాల నిష్పత్తి. లీథియం +2 and beryllium +2, their ratio of radius to be calculated. In order to calculate the ratio of the radius, we have 16/27. How can we get? Let's see. Radius of the electron for the any orbit is calculated as Rn. N means what? In which orbit that the electron is laying. That Rn is equal to 0.52 into 10 to the power -10 n square by Zm. N is equal to number of in which number the orbit belongs to. Z denotes atomic number, and Ln +2. For Ln +2, its principal quantum number is 2 and atomic number will be 3, right? So beryllium +3 is having that n value. Which orbit it is laying? Third orbit. Atomic number of beryllium will be 4. So if we put the values whichever known to you, that is given by R Li +2. So they're asking for the ratio, right? So radius of Li +2 by radius of beryllium +3 is equal to. So you can put. So whatever integer values are there, they will be just cancelled. 0.52 into 10 to the power -10 by 0.52 into 10 to the power -10. Both are given for lithium and beryllium. We can strike out. But Z is not same for both. Z is 3 for lithium, 4 for beryllium. So that we are not supposed to cancel Z value. N square is also not same. N value is 2 for lithium, 3 for beryllium, so that n square by Z remains as such. This integer value can be cancelled and into. So this is the value given for n square by Z is given for what? Lithium +2. And if you take a beryllium +3, being it is the denominator, this n square by Z will be reciprocated. We need to inverse. Whenever the equation is inversed, we have to put as Z by n square. This value is given for beryllium +3. Being it is denominator, let me reverse the value. So whenever the values are taken like this in square, this is for lithium. So 2 square can be taken. Z value is 3 here. These are for lithium plus 2. Then Z is for beryllium is 4. 4 divided with the n square. 3 square can be taken. So 4 by 3 into 4 by 9. 4 by 3 into 4 by 9. So the value will be 16 by 27. The ratio between the lithium and beryllium, second and third radius ratio will be 16 by 27. This is the way we can answer. Question 5, option 4 is the right answer. Let's go with the question number 6. Which of the following statement are not correct? Not correct to be answered. Barium compounds are generally more covalent than beryllium compounds. So barium, beryllium belongs to the second main group. Beryllium, magnesium, calcium, strontium, barium, and radium. These are the elements allocated in the second main group. As we are descending down, metallic nature increases, so that ionic nature increases consequently. So that beryllium will be more covalent in comparison to barium. So it is the wrong one, not correct to be mentioned. So that A is wrong one. ఈ క్రింది వివరణలో ఏది సరైనది కాదు. సాధారణంగా బెరీలియం సమ్మేళనాల కంటే బేరియం సమ్మేళనాలు అధిక సంయోజనీయకంగా ఉంటాయి. దిస్ ఈజ్ రాంగ్ వన్. ఎందుకంటే బెరీలియం ఈజ్ మోర్ కోవలెంట్ ఇన్ కంపారిజన్ టు బేరియం. Okay, so wrongly mentioned. Go with the option number B. The electron gain enthalpy of helium is positive. హీలియం యొక్క ఎలక్ట్రాన్ గ్రాహ్య ఎంథాల్పీ ధనాత్మకంగా ఉంటుంది. So whenever electron gained, some amount of energy will be released. But in case of helium, being it is a noble gas, so energy will be absorbed. When energy absorbed, the value will be positive. This is the way correct answer. We are not supposed to put tick here because not correct to be answered. OF2 and N2O oxygen యొక్క ఆక్సీకరణ స్థితి సమానం. The oxidation state of oxygen in OF2 and N2O are same. This is absolutely wrong because in OF2, the thing in order to answer any compound, so yes, sorry, 1 second, please. 1 second. Right, sorry for that. Here, the thing what we are discussing is OF2 and N2O are taken. OF2 means any compound you are taking into the consideration, more electronegative element will be indicated with the "ide" as the suffix. Okay, if oxygen and fluorine are in contact, obviously fluorine is more electronegative on the Mulliken scale in comparison to the oxygen. That's why we need to pronounce oxygen fluoride. Ide to be given to high electronegative element, so that this is the oxygen fluoride. But in case of sodium and oxygen, obviously sodium will be electropositive, oxygen will be electronegative, so that there is no controversial thing over there, so that we can say sodium oxide. But in case of OF2, we can say oxygen fluoride, Na2O, sodium oxide. This is the way we can pronounce. Hence, oxidation state is not same in both the compounds. Here oxygen is accompanied with +2. Here oxygen is accompanied with -2. This is the way option C will be answered. Okay. OF2 and Mariu sodium oxide lo oxygen యొక్క ఆక్సీకరణ స్థితి సమానం అనేది wrong statement. This is not correct. Then the radius of Na plus ion is smaller than that of F minus ion. F minus ion కంటే Na plus ion యొక్క వ్యాసార్థము తక్కువ. Right. So here, why we are comparing F minus and Na plus? Because both are isoelectronic in nature. Isoelectronic means though both are having different atomic number, but both are having equal number of electrons. That is called isoelectronic. Okay. Na positive is attained noble gas neon configuration, 10 electrons only we have by losing one of the electron. Right. So fluorine atomic number is 9 by gaining one electron, so that it again attained the noble gas neon configuration. So F minus is having 10 electrons, Na positive is also having 10 electrons. If two isoelectronic species are considered, then what is the criteria to mention their radius? In order to mention the radius, in case of isoelectronic species, positively charged species is having smaller radius in comparison to negatively charged species. That's the reason why Na positive is having smaller radius if we compare with F minus. Why? Because in case of sodium positive, what is the proton force? Number of protons are 11, but number of electrons are only 10. That's the reason why nuclear force is larger than the outermost electron, so that the forces are operated strongly. Hence, what happens? All the electrons all the electrons are concised maximum extent. But in case of fluoride, but in case of F minus, atomic number is 9. That means the number of protons are 9 only, but electrons are 10. Electrons are 10. That's the reason why nuclear force will be weak upon these more number of electrons. And moreover, coming electron used to repel with already existing electrons. Two forces will be operated. One is nuclear force will be comparatively less. And second is, whenever electron is coming, already existing electrons will repel with that. So two forces are increasing the size of fluoride in comparison to Na positive. Always isoelectronic species, when compared, positively charged species having lesser radius in comparison to the negatively charged ion. So this is the way the correct one is provided for this. Let's see the detailed explanation. AC are the correct answers for this one. Here, AC. A means barium is generally more covalent than beryllium is wrong. And oxidation state of oxygen in OF2 and Na2O is same is also wrong. So that AC is correct answers for this one. Let's see a clear description over there. Beryllium is more covalent in comparison to barium. So how to explain beryllium is more covalent, barium is least covalent? Because topmost element is 10e1. As we are descending down, size of the atom largely increases. Smaller atom will have highest covalent, highest polarizability as per the Fazan's rule, so that this able to give the covalent compounds contribution or sharing of electrons are possible. Whereas when we are descending down, metallic nature gradually increases, so that they are becoming more electropositive and easily release the electron and becoming electropositive and giving ionic compounds. That's the reason why beryllium forms covalent compounds, barium forms ionic compounds, so that ionic nature gradually decreases from top to bottom in any group, right? So this is wrong one. Electron gain enthalpy helium is positive. That is because of tiniest element it will be, and highly fulfilled electronic configuration 1s2 will be there. So that positive enthalpy we can notice for this helium, that is endothermic, absorbing the heat. Oxidation state of oxygen in OF2 will be +1. Each oxygen contributed with +1, and Na2O, each oxygen is contributed with -1. That's the reason why both are not same. And in case of radius of Na positive is smaller in comparison to F minus, that is because of isoelectronic species both are, but F minus has less number of protons, more number of electrons, and fluorine atomic number is 9, so that protons are 9. But in case of Na positive, 11 protons are there. Hence, Na positive is having smaller in the size as comparison to the F minus due to greater attractive forces in the sodium. Thus, 1 and 3 are not correct. So that AC we can go with, right? By this, we are going to conclude the entire session and gone with the various domains of the chemistry, and the valuable information is provided for your reference. If you're seriously aspiring for the examinations, So definitely you can go with this kind of content. So whatever you're aspiring, definitely you can achieve if you're continuously watching the channel, whatever we are posting over. And I'm sincerely requesting all the viewers to like the channel, and in order to comment, already comment. Question is provided with you, right? So the question is, let me repeat the question once again. Zinc upon treating with phosphorus giving rise to zinc phosphide in that stoichiometric equation to be drawn for that reaction zinc phosphide, that is a rat kill. And share with us parents who are more curious about the examination and subscribe the channel. Definitely we will come up with new content in the near future. Thank you one and all for your consistent listening.